Hi, everyone. Thank you for taking the time joining today's webinar. My name is Della, and I'm the sales manager at Ataccama. So on behalf of the team, great to have some of you back to our digital section. And for those who are first attending today's session, great to have you here today. So today's session is part of Ataccama APAC Digital Conference Series. And today's session is sponsored by Ascension. So Ascension are experts in designing, implementing, and supporting solutions of data, analytics, and tactical planning. So the Ascension team, they have proven capabilities in working with organizations to realize the full potential of their data assets and help achieve business objectives through data management and governance. So thank you again for the team at Ascension for supporting us and sponsoring today's session. So today's topic is AI and its roles in data management. As we all know, the world has changed dramatically over the last few months, and organizations are looking for new ways and approaches to the business and how things can be done. So in today's session, I'm joined by Roman, is Ataccama's Chief Technology Officer, who will take us through some of the challenges that face due to this pandemic and how organizations can leverage AI to revolutionize data management and governance in this period. So before I hand it over to Roman, I would like to let you know that we have a Q&A tab under the screen. We'd like to get your input on what you think, any questions that you have, and what you think of the session. We'll try to address the question at the end of the session. So without further ado, I would like to hand it over to Roman to take us through. Over to you, Roman.
Hi, everyone. Thank you, Della, for the introduction. Thank you, everyone, for joining us here today. I will switch the screen. Okay. Before I dive into the main topic, into the AI in data management, I would like to briefly comment on the current situation and how we think it actually goes hand in hand with the changes in the data management itself. So we are currently in some kind of a let's say, coronavirus-induced crisis. It has a big impact on all of the businesses that we see. We kind of try to categorize some of the bigger impacts that we see on the organizations. So kind of the most important one probably is the uncertainty of the revenue. It's hard to predict because there might be different restrictions imposed by governments. We don't know if there will be a second wave and so on. So we see businesses already reacting, trying to kind of minimize the fixed cost and go more on the flexible side. A little bit hand in hand with that, we see the typical problem with limited resources. Maybe the companies were expected to grow, hire a lot of new people, and suddenly it is not happening. And it doesn't necessarily mean that the work that we had for those new people isn't there. We just need to be able to deal without the extra people. So kind of do more with less, automate, and so on. From a different area, another challenge that we have that now more people are working remotely than before, and to some extent companies were used to remote work, but not on this scale. So suddenly there is a need to improve some processes to adopt to some remote work applications to make it more efficient and basically doable to transfer to working this way. And last but not least, we see the customers move more towards the digital channels from a traditional kind of, even for traditional brick and mortar companies, we see customers moving to these digital channels and kind of using it as a primary point of contact even more than before. So it's kind of accelerating these possible changes. So what does it mean in terms of the business and in terms of the data? So these same things, they all have some data component related to it. So when we are talking about minimizing the fixed cost and keeping it flexible, the first thing that comes to mind is the movement to cloud. We see it even more present than before. The automation and doing more with less actually goes a little bit hand in hand with that. We see the strong need in the data world for us to be able to get to the data that we need for certain use cases without the need of additional people basically helping us and preparing the dataset for us, without the need for complex ETL processes and releases and whatnot. As for the applications making remote work more efficient, suddenly if there is more application, more people collaborating, basically we need the applications to be connected. We don't want individual applications being separated, users having to do the same things in multiple applications and so on. So the need for APIs, interconnected applications, is even more pronounced than before. And as for going towards the digital channels, well, if the data quality is bad, if the data is not in the correct shape, the digital channel just doesn't work very well, right? The users are seeing inconsistent data and so on. So that like having good data is kind of a pillar stone of this. When we are talking about data management and how it evolves over time, before I go to the AI use cases as such, I want to show this kind of analogy, how we see AI impacting the data world. So historically, we started with something we call like manual data management. And in this analogy that I have, I use the common analogy for a lot of AI talks, and it's cars. So in cars, we were used to having something that's called a manual car. Some of you might still have one. I actually have a manual car, not like this one on the picture. So it still can be a nice car. It can get you wherever you want, but you have to do everything on your own. So in terms of data management, these would be like a traditional database systems. Whenever there is a new need for, let's say, integrating a new data source, you have to manually kind of write some SQL code to integrate the data source in your organization. Kind of the next step on the evolution scale that we had with cars for a very long time, it's called automatic for cars. But if you think about it, it's still pretty much manual, right? The automatic car, it helps you like reduce some of the work that you need to do. But on the grand scale, if you need to move from point A to point B, you are still doing it on your own. You're just doing a little less work. So in the data management world, you have a lot of the traditional tools, a lot of ETL tools, the data quality tools, pretty much most of what the vendors were selling for the past 20 years. It was in this area. It helps you simplify some work. You don't have to code every single line of code. There is maybe some UI where you can prepare some data flow and get it executed, but you still have to do the main work. You have to think about how to integrate this into your processes. Now the next step along the line, and I think it's even more pronounced in the data world than in the car analogy, we call it augmented. So it basically means giving the users more information to help them make decisions. So in the car analogy, we can get things like blind spot detection, like the distances like we have on this picture, lane assist. We can have built-in car navigation. We can have things like traffic sign recognition. So it's not making the car any more autonomous, but it gives the users more information that they wouldn't get otherwise to help them decide quicker what to do. In data management, it's similar to what I just described. We're just giving users some better information about the data they are working with. We show them profiles, we show them samples, we detect anomalies, we show them lineage. How did the data get there? Who is using it? How are they using it? What are the relations to other data sets? Maybe we can suggest some next best action. So this is kind of where I would say the cutting edge tools in the data management space are now at the moment. There is one next stop where this is all going, and in terms of car, it's something that's heavily discussed these days, and that's the self-driving. So in this case, for certain use cases, the tool can be doing everything on its own. So the car gets you automatically from point A to point B. What does it mean for data management? Well, for some use cases, and we will get to that in a minute, we would basically just need to express our intent to, for example, cleanse the data, to mask the data, to master data, and the tool will do everything for us. So when we talk about self-driving data management, we have actually quite a few things in mind. The systems are fairly complex. We still imagine that they are augmented in the sense I described before. So we still want to show the users all of the information. It's not supposed to be a black box. The users want to have all the information available. On the other hand, it should be autonomous in the sense that I don't have to configure everything single thing that should happen behind the scenes. I don't want to have complex deployment or operation or tuning of the platform. I want to have some kind of built-in repository of best practices and data governance processes out of the box. And I want the platform to learn from the data and the metadata that's in it, from the user actions and so on, to kind of fit better the specific needs of the organization. And of course, it needs to be self-service. On the other hand, we still think it's important to have this like complemented by some technical interface for more demanding and specific configuration needs. Let's call this a manual override. So we don't want to get rid of the steering wheel in the analogy completely. We just want the users to be able to not use it for many of the typical scenarios. So what does it mean for us, for more specifically for Ataccama, how we look at things, how we want to get here? We see basically three main building blocks that help us get to the self-driving experience. The first very important building block is the data catalog. So for any meaningful automation that we can get, we need to have kind of a repository of the metadata. We need to be able to collect and manage all of the metadata within the organization. To give an example, let's say we have an organization, we are starting a new data project. And let's say the data catalog is new initiative right now, so it's empty. So the team goes into the catalog, tries to find the data that they want to work with. The data is not there. So they create a new connection to the database they are supposed to be working with. They import the metadata. The data catalog can collect some of the metadata automatically. It can run some profiles. It can show them a lot of statistics. And they will find that there are some issues. So they can actually work in the same way as they did in past. They can use some data quality tool. They can fix it. The important part is that the data catalog kind of records all of this metadata that's collected in the process and preserves it for the further usage. And let's say the project gets completely canceled, but a month later, a different team in a different office is working on something completely different, but it uses the same data set. So when they go into the data catalog, they will find out that the data has already been imported, it has been analyzed, there were some issues found, they see some comments, how it was used, and they see there is a derived table that was maybe cleansed through some DQ tool. And they can decide what's the better source to use. Maybe they can contact the people from the past project and so on. So this is something that's, I would say it's fairly new, not the concept, but the scale in the organization, the ability to like reuse work, to have all of it documented in one place. The second big component is still to have some powerful data processing engine. This is something that in Ataccama we actually had for a long time. This is what we started with 12 years ago. So some tool that can basically read some data, apply arbitrary transformations, compute something, and store it to some target database. What we are doing in the last couple of years is kind of enhancing this engine to support some kind of machine learning use cases, to support some smart algorithms like classification and time series analysis and so on. We'll get to some of them later on in this presentation. So these two building blocks, they are nice on its own, but they don't really provide the self-driving experience. we still need something to glue it together and to kind of do the automation. So I call it the automation framework. It's something that will allow us to just provide some high-level logic, some intent, and basically leverage the information that we have documented in the catalog and leverage the engine to automate some tasks. To give a very specific example, let's say I've already documented my data warehouse in the data catalog. And I want to do something like create a copy for testing purposes. But in that copy, I need to hide, I need to mask, let's say, all of the sensitive information. So traditionally, I would have to kind of code this, let's say, table by table, decide attribute by attribute if it should be masked or not. But suddenly, I have the data catalog. I have some smart algorithms that can populate it for me. I can detect maybe the sensitive information automatically. So this is already documented in the catalog. And the automation layer, it just allows me to say, okay, take all the tables that belong to this data source, data warehouse, and for every attribute from this category of the sensitive PII data, apply a corresponding rule from the rule repository for masking. And then I can just maybe expose this as an API or schedule it, let's say on a monthly basis, to create a snapshot of the masked data for testing purposes without the need to manually configure anything else. Now, before I get to the machine learning and AI use cases in the platform, I'd like to do a quick poll. So I will launch the poll, and if you could please vote and give us some feedback. What role does AI play in your organization's data quality and governance at the moment? Okay, I can see people are voting already. I will wait a little while longer to get more results. Okay, that's interesting. So I already see that the majority of you are actually saying that there is no AI, everything is rule-based. So that's kind of consistent with what we see with our customers. On the other hand, we also see it changing quickly in the last couple of months. Okay, a few more seconds, and I will end the poll and show the results. Okay, I think that's enough. We can see the results, about 57% saying that there is no AI, but already we see 38% actually evaluating these options right now. That's, as I said, it's fairly consistent with what we see. It's not something that's widely adopted yet, but we see the trend quite clearly. Okay, let's go back to the presentation. So the first use case I want to mention is actually the first one that we implemented in our tool some time ago. It's basically smart algorithms helping with the discovery phase, with populating the catalog. So the most important one that we see is kind of detecting some domains and tags and labels for the data automatically, and kind of suggest what data is there. Not only kind of the technical statistics that was quite common for profiling tools in the past, but also identifying kind of the business meaning of the column. So we can, for example, profile data. Quite often the attributes, they don't have any meaningful names. Quite often the attributes may be more complex than just some simple value. But we can easily kind of find some patterns in data, compare it to the repository of existing kind of statistics, existing data sets that we've seen before. And based on the similarities, we kind of show some suggestions like, we think this attribute is a gender code, or this is some URL path, or this is an email, and so on. So under the hood, we are actually, for this one, we are combining both kind of the machine learning principles and the traditional rule base. So the tool can come with a repository of rules for some of the attributes. But for others, it's good to have some other options than just like manually typing in the rules. So we basically implemented some statistical algorithms that kind of capture the details of the column, and when you profile some data set, we basically compare to database of everything that has been profiled before, and if there is a similar attribute somewhere and it is already tagged in the catalog, we are saying this is probably the same thing. So whenever you tag something manually, the platform kind of learns, and next time it sees something similar, it shows it's probably the same thing, and allows you to just confirm the suggestion. Another thing that's kind of connected to that is the mapping of rules. So once we have this cataloged, we can immediately suggest, okay, so you have this email here, maybe you want to run the validation, or we can even run it behind the scenes and show the results to the user immediately. Another use case, and this is my favorite one actually, is some kind of anomaly detection. So typically in most of the data management use cases, we are processing the data on some kind of regular basis. And we don't want to spend time like manually verifying every time the data is loaded that the data is correct. And in the past, you traditionally write a bunch of rules and let some engine run them, let's say on daily basis. And if there is some threshold met, it would show us some error message. But it's very difficult to keep maintaining these rules. So we started looking at options how to kind of automatically warn users for anomalies. The simplest kind of anomalies, we call them infraload anomalies. They can be just some kind of outliers, like we can see on this picture, for example. Suddenly there is a value that's much more common than anything else. Like in this attribute, we have this artificial value system migration that's much more common than anything else, so we can report it as an anomaly. A little more complex infraload anomaly could be some kind of functional dependency that's broken. So let's say I have a columns called country and another one called continent. So every one of us knows that there is a dependency, that I cannot have, I don't know, New Zealand in Europe. But it's not, without the rule, this is not automatically clear, and there can be a lot of these like dependent columns. But we can analyze it statistically that there is a dependency between the columns, and if it gets broken, again, we can report an anomaly. A little more interesting are the anomalies across multiple loads. So we can monitor trends and seasonality of data. And we can report things like, hey, today we expected many more transactions in this table than there actually are. Maybe the load was incomplete. Or the structure changes. There are new patterns introduced and so on. So comparing to the history, analyzing the trends, kind of predicting how the load should look like today, and that it's significantly different than today is another interesting type of anomaly. And then possibly the most complex one, we can actually analyze the differences across different data sets. So similar to the functional dependency in a single column, but now it's across multiple tables. If the data goes from the source to some, let's say, target layer in some data mart, there is always some dependency, and this might get broken because the pipeline is buggy, and we've all probably seen that that the ETLs, they can break. There is a lot of them, and every now and then there is an issue, and some load doesn't work properly, and the dependency between the source and target is broken. That's the anomaly detection use case in a nutshell. in the end, it can have some visualization. So for transactional data that I said, we can show like this yellow line. It kind of shows this is what we would expect based on past experience. There should be the peak in the morning, and then maybe in the afternoon it should be less. In this case, it's probably some artificial data set. I would expect it the other way around, but whatever. Now I see that the reality was that we got the peak here around 3 p.m. And it's different than what we would expect. So we are showing it's an anomaly based on the past 87 versions. We would expect something different. So take a look at that. Another complex use case that we try to tackle is in the matching space in our MDM tool. So matching has always been the most difficult thing to configure and fine tune. And we realized that it might be easier for users to show us some examples how the matching should end up, rather than configuring exact rules for the rule-based matching engine. So we allow the users to kind of manually resolve a small number, let's say 10, 20 scenarios. We show them a couple of records, like showing them this John Smith and this Jane Smith. We think they are the same person. And is that true or not? And the user just says yes, no, or not sure. Once the user provides us with a couple of these outputs, we can kind of analyze the responses, and we can suggest some kind of new rules and basically show if you use this rule, these are the changes that will happen to your MDM system. These are the extra generated matches. And we basically allow the users to let the explainable rule-based open system coexist with this kind of machine learning approach that kind of suggests the rules for you and keeps you in line. Like it keeps the results explainable and auditable, but it lets you, it basically does the hard work of figuring out which rules are useful for you. And then there is more use cases that we don't need to go into that much detail, but maybe the last interesting one for me is the relationship discovery. It's another part of the discovery process, but now it's not on like a single table level on the profile level, but we also want to show kind of the connections between data sets. And there are different types of relations. Some of them can be maybe discovered by traditional approaches, like maybe there are lineage tools that that can like parse your ETLs and your SQL code and get the lineage of the data. But other relations, let's say across systems, are not as easy to get. But again, we can like analyze some statistical properties, and we can say, okay, so this table from your SAP is actually related. It has the same type of information as this different table in some other proprietary system. So there are systems that were maybe never connected together. But as I mentioned at the beginning, we see the need to actually integrate apps, and it's more pronounced currently, and it's actually the movement kind of started with the big data buzzword a couple of years ago. So when we are integrating these systems together, we want to see these relations, and sometimes it's difficult to get them manually or figure them out on your own. So the tools, the machine learning approach can help you with that. Another ones could be like automated transformations and corrections of the data. Things like, hey, you seem to have address here. Would you like to validate it against the official repository of addresses? Would you like to enrich it with maybe GPS coordinates and so on? So these things can be done automatically, again, based on the metadata that we find in the data set. I think now would be a good time for another poll. We've gone through the individual use cases. So another poll would be which of these use cases would you see as a priority for your data governance in your organization? So the options are detection of business terms, the detection of sensitive data, the anomaly detection that I explained, and the matching use case. Okay, I can see people voting. This time it's more even. Let's wait for a little while longer. Okay. This is interesting. My favorite use case is winning. I see most of you has voted already, so I think this is enough. We need to get back to the presentation. Let me quickly share the results again. We see that about half of you is interested in the anomaly detection, so finding out issues in the data set automatically. That's a nice use case. It kind of can be self-driving in the sense that I explained before. We don't need to really like define any rules or anything. We just say we want to monitor this data set on daily basis, and we want to get notifications if there is anything suspicious. So I really like that one. But we see that this is more even, and actually all of them are kind of interesting too. That's good to know. The last thing before we get to questions that I would like to share with you today is some kind of end-to-end scenario, and it's only a small subset of what we are kind of trying to do with our platform. But I wanted to show something more than individual use cases, but something that's kind of end-to-end. So the end-to-end use case actually starts with the cataloging itself. So when we get into our tool, we have some kind of a data catalog. So right now on this screen, I can see it. I already have some sources documented in the data catalog. But maybe I'm here because I want to connect a new source to the catalog that's not there yet. So I just click on the Create Data Source button, and I need to provide some information. I have to name the data source. So let's say I'm connecting my ERP system from the Berlin branch, Berlin office, and I have some options how to create it, but I will select the most sophisticated one. We call it Create in Document. So I want to kind of import all of the metadata from that system, and I want to run some quick discovery of what's inside. But I want to let the system decide on its own based on what it discovers in the first phase, that some of the tables are more interesting and they should be profiled, fully profiled, and kind of automatically validated by the rules that are available in the rule repository. So I click on the button and it kind of creates this dashboard for me. At first, it's empty. It didn't import anything yet. It's starting the job right now. And it might take some time, but slowly it will start populating this dashboard. I will see that in this ERP Berlin, there is some number of catalog items and it's in progress. And eventually it will get populated, and it will actually keep, let's say, getting refreshed. I can schedule some refreshes over time. And eventually, when I come back to this in a couple of days later, I will see something like this. I will see that there is a number of catalog items. I see some trends, how it evolves, some very high-level data quality. The most important detected terms, like business terms in the data set, I see there is some sensitive information in this system, and it shows some insights. So we always want to show some interesting facts, some interesting new things discovered in the data set that you might want to look at. So in this case, we are showing, for example, that there is some tables that look very similar. They are like almost duplicate tables. So that's something interesting that maybe we want to document properly. Once the catalog is populated, I can start using it for other projects. So let's say I want to search for some catalog item from this data source. So I go to the search interface and I can start using all of the discovered terms to narrow the search. So I will start typing and I will type date of birth. We know the date of birth is a business term. And I want to also limit it to some data source. And I have the list of data sources here. Let's say I'm interested in the MDM data set. And if I now trigger the search, it gives me a person table from MDM data source that has a date of birth attribute. In this case, there was only one table, so it's easy. It's the one that I was interested in. On the table, I see some high-level overview. So I see all the business terms that were found in the table. I would see the list of attributes and the terms assigned to them. I see the overall data quality that was evaluated, again, automatically. So based on the business terms found, we have associated rules connected to those terms. And we see the different dimensions of the data quality automatically computed. I can see some relations, and I can see, again, some insights. So in this case, actually, the most interesting insight for this table is that we found some anomalies there. One of them is the simple outlier I mentioned before, and another one is some kind of distribution problem. I could open the details and show the charts that I showed before, and so on. The details why this is considered anomalous. Maybe I want to see more details, like the profile of the table, the different statistics as we were used to from the traditional profiling tools. I can see more details of the data quality, how it's connected to individual attributes. I can switch to the applied checks and so on. So again, traditional kind of data quality dashboards. That's the core of what Ataccama was doing for many years now. I can see data lineage. So where the data came from, where is it going? In this case, I can also see how the quality evolves across the systems. So there were some transformations applied. So ideally, the data quality should be maybe increasing, maybe staying the same, but it shouldn't be worse in the consuming system than it was in the source. So this again gives me some nice overview of how the data was improving throughout the systems, and basically where is it going. And I can also show, let's say, the actual preview of the data. And there is actually one interesting thing that we try to show here. Some of the data may be sensitive, so I want to see the preview, but based on the role of the user, maybe I'm not allowed to see everything. So we have this concept of policies that can be entered into the system. So I can have a policy that says that people should not see the salary of a person. It should be masked. So these policies are something that's applied in general. They are not applied to a single specific table, but they are usually mapped to, again, some business term, something that's automatically discovered, or it can be manually adjusted later on as well. So if I take a look at how this policy is created, it's basically some kind of a rule like this. Like I want to say, I'm restricting access to any catalog item that has any business term assigned to it from a category of PII or sensitive information, unless the role is of a risk person, or for some reason there is also Mark Brown written here. Maybe he's, I don't know, a security officer that needs to have access to the sensitive information or whatever. So this is a policy that I can just bulk apply, and whenever I add a new data set, the automated profiling kicks in. It finds out that there is, I don't know, a birth date, which is considered to be part of the sensitive information. It will automatically be kind of disabled for all the users except for the risk department and Mark Brown. So that's it for this. So for this use case, it was just the cataloging use case. I think now is the time for questions. I think there is some questions already.
Yeah. So thank you. Yeah, I think there's one question around, Roman, you might have already shown. I think there's a question around lineage. So the question is, will the lineage show data integration and process metadata? Will the user be able to understand what calculations used to process the data as well? If yes, what are the tools it's supported? i.e. SQL, ETL tools, Teradata, SQL.
That's a very good question. So for this, we actually decided to partner with the lineage provider. So we do implement lineage for our own tools. So any transformation done within Ataccama tools, we kind of document on our own. For any external lineage, which is very needed for this catalog, we partner with external lineage tools. In particular, our partner of choice is Manta. So Manta has all the integrations for common systems, for SQL tools, for Informatica, for some other ETL tools, for some big data sources, and so on. So you can look up all the available integrations for Manta there. So out of the box, we have the integration with this. Our catalog APIs are fairly open, so we are open to integrate other lineage tools as well. But out of the box at the moment, there is this integration with Manta lineage tool.
Okay, thank you. Thanks, Roman. I think there's a few more questions here I just want to quickly touch on as well. So what are the specific algorithms does Ataccama use for domain detection?
So for domain detection, the kind of principle that we are trying to use, we call it fingerprinting. So for each attribute, we kind of create this artificial value. It's like a list of basically numbers. At the moment, we use 128 big numbers to represent the data set. And they are not any meaningful like representation that would be human readable, but it's artificially created. We actually experimented with a couple of attributes. The first version that actually we released, I think maybe 2 years ago, it was actually based on deep learning. For many cases, it was working really well, but it was kind of difficult to maintain. As you may know, deep learning, it can be quite complex to retrain regularly. So in the current version, we actually went with a little simpler algorithm. We use locality sensitive hashing to produce these fingerprints. We actually managed to get to better results, and it's much easier to kind of maintain the fingerprints. Once we have the database of fingerprints, each like attribute that we have seen before has a fingerprint associated to it. We just built an index out of it, and basically when we encounter a new data set, we compute the fingerprint, we look for the nearest neighbors in this index, and if any of them has any business term assigned to them already, we kind of suggest it can be that thing. And we kind of compute some probability based on how close the fingerprints are and how kind of unique that particular business term is in its neighborhood. So if there is like many similar business terms, it's a little more sensitive to that than if the fingerprint is very unique and all other terms are far away from it. So this is kind of how we classify the attributes using some machine learning algorithms.
Yeah. So there's a few more questions. I think one touch on the matching and merging. So does the product do merging as well, or just do data matching?
Yes, the product does merging as well. So at the moment, the merging in our MDM tool is done in a traditional approach. So it's kind of a rule-based merging. We just basically tell it how to pick attributes. So, or we basically create these groups of attributes, and for each we provide a rule how they should be consolidated. So some things you may want to take from, let's say, the newest record. Some of them you might want to pick from a particular source system that's trusted. Others you actually want to aggregate. So maybe you want to keep all distinct phone numbers from all the systems. So you don't want to just cherry pick one of them. So you might provide different rules for different parts. This would be an interesting candidate to automate as well. But at the moment, we don't have that in the tool. It's still manual and rule-based.
Okay, thank you. So another question around data modeling. Does the product support data modeling? Can it reverse engineer existing models?
So yes, in the tool we can actually provide models in a couple of different ways. One is you can still manually enter. There is like a lightweight, let's say, case tool. You can basically provide a data model to the tool. Another option is you can import it from another, let's say, metadata tool or from a case tool. Another option is you can import the model directly from the database, which sometimes works great if the relations are kept on the database level, if we have primary and foreign keys on the database layer, but sometimes it's not the case. And kind of the last option is that we can help with the discovery of these models. As I mentioned, the relationship discovery use case, it can actually populate kind of the model for you. It can suggest that these tables are related, and this is the primary key, this is a foreign key. So this kind of thing can be automated to some extent as well. So at the moment, with the results that we have seen, we believe it can be semi-automated. It's difficult to really do this to be like 100% confident. So we think it will be more like suggestions. Like we think this might be the model, and you can manually enhance it. But yes, it's possible to automate the modeling as well.
Okay, cool. So I think this question we might have touched on is about lineage. Can the lineage understand where the data is being used in reporting tools and Excel as well?
So this this is where we rely heavily on the Manta partnership. So for our tool directly, without the partnership, we would need to kind of manually enter this lineage information. But if you have a tool like Manta, it can like automatically parse the reports. So we can connect it to Tableau, for example, or to Power BI. It will analyze the reports and basically automatically capture like what tables are used by which reports. And in that case, we would be able to immediately see the lineage in our tool as well. So the idea is that, for example, for the anomaly detection use case that you guys mentioned as the most interesting one for you, when we detect an anomaly, we are also going to show you the lineage of the information. So we will show there is an anomaly in this table. These are the data sources that provided the data here, and these are the consumer. These are the reports that are actually based on the anomalous data. So these are at risk of showing incorrect information.
Thank you. So I think that's it for the Q&A. So thank you everyone for attending and participation in the poll. I hope you enjoyed today's webinar. If you have any questions you'd like to discuss with your data challenges, we'd like to encourage you to reach out to us to next will be our demo at ataccama.com. So thank you once again for joining in today. I hope you guys have a good day. Thank you.
Thank you, everyone.